I have provisioned half a terabyte logical volume, and I have attached this as an NVMe over Fabric volume to my node. So let's switch to the storage consumer, and here I'm first starting a field test for IOPS testing. Let's wait until starts running. So I'm now switching to my storage node. I want to see first actually the CPU consumption. Let's take that one. So now it's collecting CPU statistics. Well, as you can see, very much bored. The system is very much bored. We have very little usage in the user space, the user processes, and otherwise close to zero. So that's still running, just for the comparison. And then what else I would like to see? Let's have a look at the network part. So what's coming up here? Well, again, this is just around 7 gigabit. So that's a very low utilization of the network here still. So CPU is bored, network is bored, and at the same time, what's the output here? So we can see that we are around about 200K IOPS, so that's a 50-60 read-write mix that I was using. Yeah, you can see the average here is around about 93. So yeah, a little bit less than 200K IOPS, but again, this doesn't really load the system by any means. So there is good hope that in the parallelization we can scale out the IOPS easily to tens or even hundreds of nodes. So another test I would like to perform, that's really on the access latency, storage access latency. So that's I'm also using FIO for that, a little bit of a different command. So let's start that one. Again, let's have a brief look what's happening on the network. Here, more or less nothing, because that's actually a sequential read operation, and I'm assuming that CPU will also be anyways mostly idle. So yeah, same, not even possible to see much of a difference here. It's just very basic load. And then let's cancel that. I think that's enough. So what you can see here, we are in the nanoseconds range. So we have an access latency here on the right axis, and that's around about 9.5 microseconds on average. So 9.5 microseconds, that's our access latency. And that's sufficient for the highest performing applications that I'm aware of.